Hello everyone. Today I will present my homework to number 6. Design a third-order transfer function through system identification and simulate it in Simulink with MATLAB. Let's start with the assessment overview. First, let's look at the main task of this assessment. The requirement is to design a third-order linear transfer function, build a model using system identification, and do simulation analysis in Simulink. The whole process has 3 key steps. First, I need to decide on a third-order transfer function. Then, generate necessary data and use it for system identification. Finally, verify the result through simulation. For this assessment, I chose a specific third-order transfer function. Its form is this. Let me explain 2 important points about it. Order verification. The highest power is S in the denominator is 3, so this is effectively a third-order linear time invariant system, which meets the assessment requirement. Follow analyze. If we factor the denominator, we get this. This means the system has one real pole and a pair of contract complex poles. This pole affect how the system responds. Also, when setting up this function in Simulink, we need to input conflicting correctly. The number later conflictly is 4851, and then denominator conflictor is 158.5 6282. Since the denominator is this, Simulink use these conflictors to run the model, so inputting them accurately is very important. Next, let's look at the overall structure of the Simulink simulation model. It has 4 main parts. First, sine wave source. This creates the input signal to test the system. Third, order transfer function block. This is the cruel part here. The signal goes through the transfer function we designed. Single processing models. This include gain and summation blocks to adjust the signal if needed. Observation models. We use a scope and data logging tools to check the results. The signal flows like this. The sine wave goes into the transfer function block. Then the output signal goes through signal processing. After that, we observe it with the scope and log the data. Also, we collect data from the sine wave source branch too. This helps with later system identification. Data collection is a key step for system identification. We need two types of singles. Input single. This is the expectation single from the sine wave source. We all use this single later to identify the system. Output single. This is the response single after the input goes through the third-order transfer function block. We record the single using tools like AutoSimout in Simulink. Why do we collect this? Because system identification needs input-output data pairs. It uses how the system records to a no input to build a model. Without these pairs, we can't do identification. For system identification, I use MATLAB's System Identification Toolbox. It's helpful tool for these tasks. The process is simple. First, import the input-output data we collected into the toolbox. Then select the third-order model structure, since we know our system is third order. The toolbox will automatically fit the date to create an identify the transfer function. After getting this identified function, we need to verify it. How we compare the characters of the identified transfer function with our algorithm transfer function. If they are similar, the identification is successful. Now let's look at the date dimension response from the simulation. This is what based on the scope. In scope waveform, the yellow curve is the input sine single, the one we set from the sine wave source. The blue curve is the output response of the transfer function. From these curves, we can see two important characters. There are differences in amplitude and pace between the output and the input. This shows the dynamic nature of the third-order system. Its output doesn't just copy the input. It changes based on the system properties. To remember the pole at S is 0, we talked about it earlier. Because of this pole, the system is greatly stable, so the output shows an integrative response. It doesn't blow up, go to inverting, or die down quickly. It responds in a steady, slow charging way. Finally, let's summary what I learned and achieved in this assessment. How I know some knowledge points. First, I know how to judge the order of the transfer function. Second, the full process of system identification. Third, how to build and use the model simulation model in Simulink. Assessment achievements. I complete the entire flow, starting with the models, then doing data collection and system identification, and finally verify everything with simulation. Through this, I successfully checked the characters of the third order linear system, like its response to a sign input and the effect of these pores. That's all for my presentation. Thank you, Professor. This is my all answer. Thanks for your listening. Goodbye.